What we are hearing from customers and where the industry is going is more and more customers, they don't want a dashboard. They don't want something to just tell them, hey, this is how your system is behaving. Okay, but tell me what can I do better or what actions can I take to make the system perform better.
As GenAI expands across organizations, that means there is naturally more to manage across the IT landscape. And it's even more challenging when enterprises use thousands of apps to do it. The cost of something breaking behind the scenes can be massive. Observability is a cutting-edge field in AI technology that keeps your business moving despite the complexities that come with scaling AI. So how do you build the right tech stack to ensure seamless IT operations? Today, we're joined by Vikram Murali, the VP of Development for IBM Automation, to shed light on exactly how you could manage all of the new technology in your stack. Welcome, Vikram.
Hey, thank you. Thanks for having me.
Today, we're going to be talking about observability. So before we even dive in, can you tell me what is observability?
Sure. So observability is about understanding the core working of a system or an application. In its simplest form, that's how I would explain it. It's also about understanding why a system or an application behaves in a particular way, what you can learn from it, and how you can take proactive actions to avoid very costly disruptions, both monetarily as well as, reputational damage that could be caused to the line of business.
Was observability always a part of automation, or is that something relatively new?
Observability has been around for quite some time. I would say it probably started with traditional monitoring, and monitoring didn't cut it. So, we've been observing systems for a long time. It's about, okay, so now you observe a system, you understand why it behaves in a particular way. What actions can you take? And for those actions, you need automation. So that's how it ties into automation, and specifically IT automation.
I wonder if the amount of data over the years actually affects the efficiency of observability, because you have all the ways these systems behave. You have records of it. You know how it works. So now you have AI influencing the way observability actually affects the tech stack.
Absolutely. So one of the ways we observe a particular system is we look at logs and traces and metrics. You can just imagine with applications becoming more complex, with a lot more data being produced, the amount of data that we are collecting through logs, metrics, and traces is just humongous. It's not possible for traditional older methodologies, to sift through that data and make sense, trying to understand what's going on. That's why we use AI itself. We also use Gen AI to understand the pattern that we see in these logs. And without that, we wouldn't be as productive as we are today without the proper observability systems in place using Gen AI methodology to go through all of these data.
I feel like LLMs, the foundation models, are just so well suited for finding patterns in these huge amounts of data.
Yeah, absolutely. Like I said, the data, there is so much data. Traditional mechanism using business analytics or algorithms is just not going to be enough, right? You need a system that is intelligent. You need a system that can go through data as fast as it is coming. Most of our logs and traces we collect every second. You can imagine, the amount of data we are collecting on top of what an application is doing. There's no way a human can go through that data to understand what actually is going on. So that's where Gen AI becomes very, very crucial for us in observability.
Observability tools that we use Gen AI, but as the enterprises or any corporations are implementing Gen AI solutions, how does that affect the observability?
So I usually say observability is a day zero task. And the reason is when you're trying to build an AI infrastructure or a data infrastructure, the number one thing you want to look at is make sure that you're observing that particular stack. Now imagine in the era of Gen AI, GPUs are so expensive. There's a high failure rate in GPUs. And, maybe you have 100 GPUs for a particular development team, and only 50 or 60 of them are actively being used, and the others are sitting idle. If you don't observe that particular system, and if you don't have automated actions, being taken based on that observability, then you're just sitting on expensive hardware while development teams are waiting in the line to get their share of GPUs or infrastructure or whatever hardware it is. When we talk about Gen AI, when we talk about, okay, how do you build these models, train them, you need to make sure that you're observing the stack. You need to make sure that your expensive infrastructure is being used optimally. And if it's sitting idle, then you can take some automated actions by assigning it to the right teams to get their jobs done.
But honestly, that something I didn't consider is the cost of the hardware just sitting idle. Like I know that even in my working day, I have an application that I have a license to, but if I'm not using it, I'll eventually get an email that says, okay, listen, you haven't, you have a license for this, Photoshop or whatever it is, but you haven't used it. Do you really need it? I imagine similarly, that's what observability tools can do for like hardware.
I mean, if you look at Gen AI and agentic frameworks, right, they are everywhere now. And customers use it in code development as well as day-to-day operations. So we are now able to build more with less, if you will. So which means more applications are coming out. Millions of applications will come to existence in a very short period of time. If you look at the older tool sets or custom tools, or if you're just using monitoring, age-old monitoring, that's not going to cut it, right? So you need to make sure that you have healing systems, you're able to take actions, like in the example I said, making sure that your expensive infrastructure is used optimally and to the fullest.
Do you ever have it like totally automated? Like you say, okay, we have a threshold, 75 GPUs are just sitting idle, just instantly just cut them off.
Yeah, absolutely. So it's not only just GPUs, but maybe you're doing development on a hyperscaler. Cloud infrastructure is expensive. And especially when you're using it for development and the developer forgets to shut down the VM or the EC2 machine or whatever infrastructure at the end of his day, and it's just sitting idle there, we are continuously monitoring and observing that particular system, and we can take action where we can say, he's not going to use it, he's not going to come back until Monday morning. Nothing is running, so maybe we can idle it, throttle it, we can bring it down to the minimum number of CPUs and memory. Or even better, we can completely shut it down and save money for the next 2 days until he comes back Monday morning to continue what he's doing. So there are a lot of automated actions we can take.
The idea of like, okay, I have a server up and running. I'm doing some work on a Friday afternoon. I'm like, all right, but now it's time to go out with my wife. I'm going to take her out to dinner. There's going to be an automation tool that says, okay, he does this every Friday at about 5 p.m. He's not going to be working on anything that he's doing on this hypervisor. Let's just spin it down for now.
Exactly. And we look at other things as well. Sometimes what developers do is they run tests, or they run some programs, during the night times or the weekends. So we look for activity, and there are patterns that we can see that nothing is happening. No processes are running. So which means it's literally idle. And yes, we can take automated actions of bringing those servers down.
Yeah, this feels like this is exactly what the budgeting department of any corporation wants to hear, that you can really cut costs. But can you take me a little bit under the hood? What is the extent of the observability stack? Like how deep does it actually look into an enterprise environment?
So usually when we, and I mentioned observability is like a day zero problem. We start with the infrastructure. And by infrastructure, I'm talking about we can start as low as the network. We look at network, we look at DNS routing, we look at performance of the network and resource utilization at network level. So we have observability tools that help you at the network layer. The next layer up is going to be your core infrastructure, like CPUs, GPUs, memory. We are looking at your hardware specifically, right? So we have observability tools in that layer. Now you go a little bit above that, you have your application. So you deploy your application. We can look at your applications from an application perspective, which is how performant is a particular application. If there are 500 users connected versus 1,000 users connected, we can look at patterns on how an application is performing. We can also help with root cause analysis. If your application goes down, the first thing you want to find out is why did it go down and how can I avoid it? We have enough information when we observe the applications that we can go back and tell you. It can help you with root cause analysis as well. So that's the application layer. But another piece of the application layer, which ties to the infrastructure, is also what we call application resource management. We have tools in that area which can actually balance resources between applications. It can say this application is allocated, let's say, 20 CPUs. It doesn't need it. It's using 5 or 6, right? Can I balance it? Can I take it from it and give it to another application, which is like 80-90%, at the threshold level? So we can do application monitoring, application observability, both for performance as well as resource management. And then, of course, we have the FinOps area, right? We have tools that can help you manage your spend on a cloud. Every cloud is different. Every hyperscaler is different. Your discount rates on specific plans could be different. So we keep track of all of that. And we can tell you, hey, last month by this time you used this much, but this month you already crossed the threshold. And these are the activities that you can take to bring your cost down. So this entire stack that I just mentioned, starting from network to infrastructure, all the way to the application, we have tools that can help you throughout that stack.
So is observability always tied with automation and remediation? Or can it just be observability?
It can just be observability, but I think what we are hearing from customers and where the industry is going is more and more customers, they don't want a dashboard. They don't want something to just tell them, hey, this is how your system is behaving. Okay, but tell me what can I do better or what actions can I take to make the system perform better. That's where observability gets into the next set or the next stage, I should say, where you can take actions. And like the example I gave you, when you're collecting logs and metrics every second, imagine the amount of data we have, and that could be 500 actions that you could take. We even prioritize those actions and we tell you what are the lowest hanging ones and which gives you the most bang for the buck. So we prioritize those actions for you as well. And most customers may or may not allow us to take direct actions in production, but that's why we connect to change management systems as well. And we say, go take this action. And through the change management system, if we get the permission to go execute that action, we can execute as well. So that's where the automation comes in.
It sounds like a lot of customers always want that human in the loop to make that decision-making process. Like, okay, make this change. You've alerted me to it, but run this remediating action.
The human in the loop will always be there, but what we are trying to automate and make that decision-making faster is that we should provide that human in the loop with all of the information required. That way, with the press of a button, he can say, yep, I've read everything. This is good to go take the action. But there are some instances like the development servers that I was giving you an example of, where it's not production, and usually you can take automated actions even without human in the loop.
Is this a real competitive advantage in terms of creating better operations and supply chain management? It's an IT tool, but it seems like it applies elsewhere.
Yeah, we ourselves. So everything, all of the examples that I gave you, these are examples from within our company, right? Our CIO's office uses it. Our CISO team uses it. IBM development, we ourselves use it. WatsonX.ai, for example, uses some of the application resource management tools that I was talking about. So I like to call it, we eat our own dog food. So we are client zero. So we use it everywhere. It's just not one specific team. There are multiple teams within IBM that actually use many of these tools on a daily basis, I should say.
So, okay, a lot of companies probably have observability strategies already implemented. What separates good tools from bad?
Most customers do something in the observability area, but what they do is they create some custom tools, or they use tools which were developed for applications which were not built in this era, right? And over a period of time, and by the way, this happens to us as well. So I'm not just saying, we are perfect, but there's always it's progress not being perfect, right? So what happens is teams become silos. They work in silos. They have different tools. You don't have, the right hand is not doing the same thing that the left hand is doing. It's like two different things. They don't know what they're doing. People keep throwing more and more resources at it and more money at the problem, rather than saying, you know what, I'm going to standardize, right? Let me provide my line of business and my development teams a standardized set of tools. And once I have that standardized set of tools, they don't have to, your actual application developers and your business doesn't have to go figure out what observability tool I should use. It's all there, right? And usually it's done by CIOs and CTOs. They set the strategy. So have a strategy that where you're thinking about observability as a day zero problem. And when you're building your infrastructure and your IT landscape, your data landscape, make sure observability is part of it. Then the teams using those infrastructure, they don't have to worry about observability. It's all there from day one.
Can you give me some examples of necessary functions, the functions of an observability tool that need to be there?
So one of the things that we look at closely is, yes, you're observing your application for performance and for resource. One of the new areas that is emerging right now is called resilience, right? How resilient is your application or your environment? And the reason for this is, if you look at legal frameworks that are emerging, like I'll give you an example, the Digital Operational Resiliency Act in the EU, where it's mandatory for companies doing business in the EU starting at the beginning of this year to certify that your applications that your customers depend on are resilient. Now, how do you calculate resiliency, right? How do you say, yes, I'm resilient? So that's where we come specifically. We are very opinionated with how to calculate resilience. You need observability tools for that. But the areas that we look for in resilience are things around, is your application usable? We call it usability. What is the high availability of your application? What is the recoverability aspect of your application? What is the maintainability aspect of your application? What security structures that you have around your application? So we look at all these different dimensions, and that is how we come up with what we call as a resilience score. With the resilience score, we also tell you why your score is where it is. For example, our goal is that your application should be 100% resilient. You probably may never get there, but at the same time, we don't want it to be like 20, 30, 40% resilient, right? So we also give you what are the factors influencing that resilience score and what actions you can take to make that score better. And one of my favorite examples is, most cloud providers, hyperscalers, they usually give you an SLA of, we are 99.999% up, right? 5 nines. Yes, the application was up, but usually if 1,000 users connect to it, and now 1,000 users are connected to that application, but what used to take milliseconds for them in that application now takes a minute or 2 minutes. That's not usable, right? That's why we are very opinionated on coming up with these 6 NFRs, as we call it, dimensions that we measure. And with that, as I said, we come up with a resilience score. And then we tell customers, why is your score the way it is? And what actions you can take to better that score.
What do you think the motivation for the EU was to put that into law?
More and more of our day-to-day life, we are depending on these applications, right? Anything from you go to a bank, you want to use an ATM, or you want to pay a mortgage, you go to a railway station, or you're on a web and you want to book a train ticket or an air ticket. We don't want to go to these applications and find out that they are down for 5 minutes or 10 minutes or they're not usable, right? There are more and more attacks happening as well. A lot of security vulnerabilities that are popping up on a day-to-day basis. So if we don't have these secure developmental practices, and if your operations teams don't have these secure practices that they are following to make sure that they can catch these things before something bad happens, that is, I believe, the main reason why governments around the world, DORA is one such one, but there's something coming up in Asia, there'll be one in US, more and more companies are doing business across the world. So I believe that's one of the reasons why you see governments coming up with we have to have a structure that we have to follow, and everyone needs to follow the same structure. Everyone can't just come up with their own definition of what resilience means, for example.
You mentioned something about predicting a downtime or predicting something going wrong. So predictive analysis with observability is, I'm assuming, one of the biggest parts of the function, right? This is what people want. Do you have any examples, like specific examples? You don't have to name any names, but any specific examples where you caught something that was about to happen that would have been catastrophic?
Absolutely. So I'll give you an example of application performance, right? So we have hundreds of thousands of customers using applications that they have come to depend on every day, like the ones I gave you examples of, like banking, retail, transportation, ticketing, and so on. By using the right observability tools, at least the customers that we work with that use them, we see a significant drop in the outages as well as disruptions, right? If these observability tools and strategies are implemented from day zero. I'll give you another example. Our own IBM SRE teams, we operate environments where we have services that our customers have come to expect continuous resiliency 24/7. And how do we ensure we provide that level of service? So now we can measure ourselves the amount of time that it takes to automatically, say, rotate certificates, right? Automatically apply patching to common vulnerabilities. We don't have to wait for 2 weeks or 4 weeks to address a particular vulnerability. We can do automated patching now. So all of these, I can definitely say that has reduced the number of tickets customers open with us. That's a great area of measurement. And we also look at disruptions, how many times an application went down. Yes, it's up 99.999% of the time, but are customers using it the way we expect them to use it? Are we hearing complaints? All of those things automatically just drop down. The certificate example that I gave you, in a given year, and this is a favorite metric I have, it's not a good one, but in a given year, we get about anywhere from 700 to 1,000 tickets where customers are calling us saying, hey, my application went down. I have no idea why it went down. So having observability tools helps you. Remember, I told you about root cause analysis. So we can pinpoint why an application went down. And two, we can actually help manage your certificates. We can actually help rotate those certificates automatically. You probably don't even need a change management system in place because you're not going to let your application certificate expire before you're going to rotate it, right? So that's again a great example. And, we do see the number of tickets completely going down, especially the ones that allow us to automate these actions. I would say it probably came down to even zero, but that is a significant drop, 700 to 1,000 a year, down to maybe the teens right now.
It's unbelievable. The big thing I'm thinking about, especially because like IBM uses thousands of apps internally, I'm thinking about myself. There's a tremendous amount of data that you have to sift through because you're going to train this observability model on a tremendous amount of data. But how do you actually get the good data from that? Like, how do you know what data is actually appropriate? Or do you just put all of it in and see what comes out at the other end?
I know. So, it depends upon the observability tool as well. Like one of the tools that we have, that collects logs, I said, every second. Yes, it does collect a lot of data, but at the same time, if you don't collect it every second and you collect it once every 30 seconds, you're missing the picture. That's not continuous observability. At that point, it's your back to traditional monitoring, right? So we are constantly coming up with solutions where it's a balance between how much data that we collect and how we can make sense of the data. There are a lot of tools, like some of the tools like Concert, I will mention, that we use for application lifecycle development. We really don't collect huge volumes of data. We just collect metadata, right? We collect information about where your repositories are, who the owners of those repositories are. That way, when a vulnerability comes in, we know where to route that particular request. We know we can even generate the code to fix a particular vulnerability, and we can assign it to the developer who actually wrote that piece of code. So for those tasks, we don't collect a lot of data. But that's where GenAI comes into the picture as well. So we have good information, solid information about your application, about your environment. Now, how do you tie all of this together? And what we see in the industry happen is most customers, especially if they have custom tools, they are trying to do it themselves. They are becoming the aggregator, right? They are putting BI tools on top, exporting it to Excel spreadsheets. We are like, we don't want that. We let us just give you a dashboard where we show you everything, where you can take actions. And that's going to help you bring your risk down and increase your resilience.
In your field, in automation, has anything happened recently that was just like mind-blowing to you?
I would say the advent of Gen AI and agentic AI, right? AI agents coming in. Imagine you can take actions like those where you don't have to wake up your ops team in the middle of the night when something goes wrong, and an automated action actually helped take care of the application. That is how the application is resilient. And your teams can come back and do root cause and find out, what action the system takes. Now, you also have to build trust in the system, right? So these things customers have to, probably they will implement it in development and test machines first, and they will monitor it for a period of time to see, what are the automated actions? Can I trust it? 9 out of 10 times it's doing the right thing, or maybe even 10 out of 10 times is it doing the right thing? And then they build the trust on the system, trust on the tools and the automated actions that it can take. And then from there on, they are like, okay, I'm okay to allow these things to be automated in production as well. We see a massive shift. I would say maybe even 2, 3, 4 years back, customers would stop with the recommendations we give them, and they would go, do what they did manually. But we see more and more automated actions take place, and that's thanks to the proliferation of Gen AI, especially the agentic frameworks that are coming into play right now.
Agentic frameworks, I know we discussed before you came on, you don't get to be on the keyboard in the code as much as you would like now that you're in your position, but implementing an agentic solution, and one of the craziest things to me was just like the philosophy of it, right? You're looking at an agent, you're saying, okay, like it's in the name, I'm giving this block of code agency to make a decision, to call tools. And I could see that implemented in something like observability or remediation or something like that. It makes my hands sweat a little bit just thinking about like taking away my control of what the application is going to do. How do you balance that? Because we know that it's such a powerful tool. The agentic framework is such a tremendously powerful tool. At the same time, you're giving it agency to make its own decision. So how do you balance the, effectiveness and then also the danger, in my opinion?
This goes back to the trust factor, right? So our own developers use agents, they use automated tools, they use code generators, if you will. to write code, maybe 10, 20, 30% of code, we are trying to see if Gen AI can help us generate it, automated test cases, right? So right now it is an aiding tool. So it's not going to replace a developer, that critical thinking that a developer has, the features that we have to develop in the product. So all of that we need our, core developers and development team to concentrate on. But the repetitive tasks, right? Every time we put new features out, we need automated test cases. Can that be written by, Gen AI? Can code be generated automatically? The example that I gave you around vulnerabilities, vulnerabilities, we hit hundreds, if not thousands of vulnerabilities on a daily, weekly basis. The question is, can I aid the developer? I know the developer wrote the code, but can I aid the developer in generating the fix for that particular vulnerability? The developer still has to be in the loop because he has to agree to, yes, this is the block of code that needs to be replaced with this. But, he's going to accept that more and more if he can trust it. If you can see the system generate that code over a period of time with very high levels of accuracy, then the trust comes in, right? And I see that needle moving more and more up, I should say. I mean, there are areas where things don't work the way we expect it to work, from time to time. But once you build that trust and you see agentic frameworks and Gen AI doing what it's supposed to do more and more, it's an amazing productivity booster, right? We can get more things with less. And by less, what I mean is less time. So if I have a roadmap to deliver a feature, let's say 6 months down the line, with some of these aids or aiding tools, we are now able to do it maybe a lot more faster. I would say half the time or even faster.
All right. So the people listening to the podcast right now are obviously into automation. What questions should they be asking when they turn off the podcast and they want to start implementing some kind of observability solution?
I think the one thing to take a close look at is to look at your teams to see what they are doing. Look at your observability tools that you're using. The first red herring is going to be if you're not using a standardized tool and you have, 2, 3, 4 teams using as many number of tools, which means they are completely siloed, right? So it's very important to have standardized tooling that massively reduces the overhead that your teams have to go through. And it also makes sure, even from a CIO, CTO, CISO perspective, that all teams are doing things the same way and they are not completely siloed. So that's the first thing that I would definitely recommend. The second thing is work with a vendor that has implemented these in multiple places, and I would say probably even within their own organization. Like I said, we are client zero to a lot of things that I just told you. And we can give you examples. We can, work with you to show you what we were doing. Remember, I told you we are not perfect. So we came from that level to where we are now. And we are improving, we are progressing. And, the savings in time, savings in dollars, savings in, the amount of disruptions, I would say, that we avoided, we can share those with you. And I would, just not IBM, but any vendor you're working with, those are the things you need to look out for, right? How widely is it being used? Are these tools scalable for your business? So those are some of the areas that I will look out for.
Vikram, this has been awesome. Thank you so much for spending time with us.
This has been awesome for me as well, and thank you for having me.
For the rest of you, thank you as always for listening or watching. Please make sure to follow us on YouTube or wherever you're listening to this podcast. We'll see you soon.